Good day, everyone. You are welcome to Teacher Tutorial. This is the best science platform that you can ever have on planet Earth at the moment. Now, today we are considering problems involving atomic structure. Please don't forget to like, comment, subscribe, and share this video. Very important. Now, we are taking problems involving atomic structure, but in this problem, we are going to consider how to write the electronic configuration of an element, how to draw the orbital diagram of an element, and how to know the number of unpaired electrons and the number of orbitals the element has. Now, if you look at the right side of the board, we have orbital diagrams. For S orbital, it's one box. P orbital, 3 in 1. Then D orbital, 5 in 1. Then each box represents a sub-energy level. Now S takes maximum of 2 electrons, P takes maximum of 6 electrons, and D takes 10 electrons. F is 14 electrons. There are 4 types of orbitals: S orbital, P orbital, D orbital, and F orbital. The F orbital is not represented here. Now it takes 14 electrons. Now if you are writing the electronic configuration of an element, you follow this direction. You write your 1s to 5s, 2p to 5p, 3d to 5d, 4f to 5f. Then follow the arrow. You start from the tail of the arrow. Don't forget that S takes maximum of 2 electrons, P is 6 electrons, D is 10 electrons, F is 14 electrons. Now let's take a look at this question on the board. We are told an element has an atomic number of 13. The first sub-question, we have to write the electronic configuration of the element. So we are starting with 1s according to what we have at the right hand of the board. So the number of electrons is 13. So the electronic configuration then will be 1s2 followed by 2s, 2s2, follow the arrow on the board. You have 2p6, 10 electrons already, then 3s2, followed by 3p1. So this is the electronic configuration of the element. Now the second question, we have to write the orbital diagram of the element. Don't forget, in writing the orbital diagram of an element, you have to obey 3 rules that govern electron filling into orbitals. 1, Pauli's exclusion principle. It states that 2 electrons in the same orbital cannot have the same values of the 4 quantum numbers. Then Hubble's principle states that electrons enter into orbitals in order of increasing energy. Then Hunt's rule states that in filling of an orbital, electrons enter into degenerate orbitals singly before pairing. These 3 rules have to be obeyed. Now we are writing 1s. S is 1 box. So this is 1s. 1s has 2 electrons. So one of the electrons faces up, the other one faces down because of Pauli's exclusion principle. 2 electrons in the same orbital cannot have the same values of the 4 quantum numbers. Then we move on to 2s. We have to raise the box in this case, 2s2. Why are we raising the box? Because of Hubble's principle. It states that electrons enter into orbitals in order of increasing energy. So 2s should have a higher energy than 1s. So we put the 2 electrons there, that is 2s2. We move on to 2p6. Raise the energy level 2p. 2p6, 6 electrons. They will enter singly before pairing, according to Hunt's rule. Then we go to 3s. 3p1. Now we move on to the next question. We are told to get the number of orbitals in the atom. Each box stands for an orbital. Now we have to count the orbitals. This is 1, to the second one. Then this is number 3, number 4, 5, 6, and 7. So number of orbitals is 7. There are 7 orbitals, 7 boxes containing electrons. The number of boxes containing electrons gives you the number of orbitals. There are 7 boxes that have electrons. Then we move on to number 4. Question number 4, how many unpaired electrons has the element? Number of unpaired electrons is 1, because it's only 1 electron that is not paired. Only 1. The rest of them are paired. The 3p electron is not paired. It's occurring on its own. So we have 1 unpaired electron. So thank you very much. See you in my next video.